Hello and welcome to today's training on HDBT 3.0 and the future of video distribution in the residential market. This is a re-recording of the exact same training that was given at CEDIA Tech Summit in Leeds by myself, Jonathan Regalado-Hawkey, on the 27th of April of 2022. The idea of this training is to basically give you an introduction to HDBT3 and how that's going to affect the residential market. And the agenda will be basically a quick recap into HDBT, a very quick overview of how the technology works. We'll talk about the challenges of over the past year and the solutions of how HDMI 2.0 was being sent over an HDBT link. We will talk about why HDBT 3.0 is such an important step and such in moving forward, and the different type of cabling and how the new technology affects the cabling and what considerations you must take as an installer. And finally, as you move on to larger installations, whether you want to consider HDBT or maybe a different video over IP solution, comparison between the different technologies and solutions available in the market when making a decision. So let's look first of all at HDBT and how it started. So if you look at any audio video distribution solution today, you'll probably encounter the four following interfaces that you need to extend over a certain distance. First of all, you might have Ethernet connectivity. You'll probably have HDMI video or DisplayPort in some cases. You also have a digital audio such as SpeedIF that you might want to extend. You might also have analog audio as well as RS-232 for control, USB extension for, let's say, meeting rooms, and finally you also obviously have power. And all of these signals, what was really important about HDBT when it was first introduced more than 10 years ago is that it's able to take all of these different interfaces and send them simultaneously over a single cable up to 100 meters. And that cable is the obviously category cable, anything from Cat5e and above. So if you ever go to an HDBT sort of training given by the Alliance, you will see what they call the 5-play sort of support. And what do they mean by 5-play? It's really technology convergence over that single cable. So one play would be uncompressed video and audio. The second would be control signals. You're able to extend IR, CEC, RS-232 over that cable. As well, you're able to extend Ethernet. That can be 100 base T or 1000 base T. So that's 100 meg or 1 gig Ethernet. You're also able to extend USB 2 signals. Let's say, again, for a meeting room, a large meeting room, you want to extend a keyboard and mouse, maybe even a camera and so on. That can be sent over the HDBT link. As well, all of these signals are sent simultaneously from a source to a sink, but you're also able to send power over that cable. So in theory, you'd be able to power an attached device, and that power can be anything up to 100 watts, depending on the obviously manufacturer's capabilities. So how did they achieve this cable? And this is where it gets a little bit technical, but please bear with us. When HDBT1 was announced, first of all, HDBT is an asymmetric full duplex sort of operation type of technology. So that means that you have a main link going from the source, let's say a Blu-ray player, all the way to a sink, which is connected, let's say, to a display. So your main link is supporting what's called a 500 mega symbol per pair, and each symbol is sending what's called PAM16. Now I'll mention this a little bit later, but what PAM16 does is send 4 bits per symbol. So if you have a 500 meg times 4, which is the 4 bits per symbol, you're actually sending 2 gigs per differential line. And if you know a cat cable, you have 4 lines. That means that's 8 gig per link going from source to sink. and you're able to send it over a cable, as I mentioned, over 100 meters, and that 100 meters is classified as 5-meter patch cables and a 90-meter, straight run. Although you can also do 100 meters direct with no patch cables, but that is what is supported by HDBaseT1, and it was able to send 1080p 60 or 4K 30 hertz uncompressed over a 100-meter cable, as well as all the other different signals that I mentioned before, 100 megabit Ethernet and so on. It also has a return channel, which is sending 12.5 mega symbols at PAM8, which is 3 bits, and that equates to 150 megabits per second that you're able to send on the back channel, and that's enables you to send basically 100 megabit Ethernet bidirectional. So you can send 100 megabits Ethernet one way or the other way. So that's why you also have a back channel. When HDBaseT1 was announced, again, more than 10 years ago, it really became revolutionary, and it became a de facto standard for, AV distribution, not just in the home, but also in many professional AV technologies. When HDBaseT 2.0 was announced, I think it was 5-6 years after HDBaseT1, there really wasn't a big revolution in terms of sort of main link upgrading the bandwidth. It was still 500 meg symbols. It was still 8 gigabits per second over the cable itself. There was, however, an improvement on the return channel. So that was doubled in order to accommodate 25 meg symbols, which meant 300 megabit per second return. And that was because it was able to introduce extension of USB 2.0. So USB 2.0 was not really supported in HDBaseT1, but it was supported in HDBaseT2. As you know, USB extension is not really a big feature or in the residential market, but it was quite a big feature for meeting rooms, for example. So if you're making meeting room products, so that would be something that that you would be looking at. The other big improvement is error correction. So what this allowed you to do is that it allows a better, how shall I say, it offered a better immunity from external noise. So if you're now bundling lots and lots of cables together, and maybe they'll be close by to other noises of noisy equipment or cabling, it doesn't affect the signal inside because it has a much more robust error correction. So if there is, it has a better immunity from external noise is what I'm trying to get at. So if you do have external noise affecting the HDBaseT signal, that is actually corrected and it's all being handled by the technology itself, and you have no really sort of picture quality loss or anything like that. Very briefly, I mentioned PAM16. What does it mean? What it really means is that you have 16 different levels that a single signal symbol can be sent at, and obviously that depends on the 4 different bits. So anything from level what they called -15 up to 15, although there's got a 2-gap interface, but basically you're going from 1000 all the way to 000 at the top and anything in between, and that means that what you're sending from source all the way to the sink can be in any of these levels. Obviously, as you can see here on the receiver, what you're receiving after 100-meter distance does not look what was being sent on the source. So if you ever put your hand, just as a test, put your hand on an HDBaseT1 receiver, you will notice it's a little bit warmer than the transmitter. The reason is because the receiver is working extremely hard. And this is the chip inside of the product itself. It's working extremely hard to basically decipher exactly what level was sent by the source itself. But that's it. There's a lot of work going on there. Something important for you to know is that HDBaseT does not work or use the same signaling encoding as Ethernet. It uses PAM16, while as Ethernet uses MLT3 usually. So what that means is that you can never put an Ethernet switch in between HDBaseT signal. Normally in HDBaseT, you will have a point-to-point from your matrix, from your transmitter to your receiver. Separately, although HDBaseT does support patch cables, as you saw in the earlier slide, it is really recommended that when possible, do not use the patch cable or even a patch panel in this case, because you would have a short cable then. It is preferred when possible to have a straight run. And the reason for that is because every time that you have a patch cable or a connection, you're basically having a slight discontinuity, which might affect the distance, as we will see later on. But in general, you know, it's not that it's not supported, it's that it's recommended that don't use a patch cable if you don't have to, really. And HDBaseT really is everywhere. You obviously, as you know, more than 10 years ago, the founding members were Valens, Samsung, Sony, LG. So some Valens was the semiconductor, and then you have some heavyweights in there of AV, such as Samsung, Sony, and LG. You have different tiers of members. And we have the contributor members, and this is people like Pulsate, where we basically have the ability to contribute to the standard. We participate in a lot of the working groups, and in fact, we made several recommendations to HDBaseT 3.0 specification, which were adopted, and we're very proud of that. So that's what a contributor member really allows you to be involved in the working groups. You can also become, obviously, if you want to use the technology and that's it, and you don't want to be part of specifying or making recommendations and working with other manufacturers, you just want to use the technology, then you can also become an adopter member. You pay your fee, and all of these manufacturers do that today. In fact, the vast majority just pay a fee to become an adopter member and use the technology, and that's it. Okay, so that's a quick intro to HDBaseT. I'm sure that most of you are familiar to the technology, but let's look at the issue that we have over the last few years: how to extend HDMI 2 over an HDBaseT1 and HDBaseT2 signaling. So HDBaseT specifications 1 and 2 really support anything with a TMDS character rate of up to 340 mega clocks, basically megahertz. That equates to 10.2 data rate. In terms of resolution, which is probably what you care about the most, this actually means that HDMI 1.3 and 1.4 are supported uncompressed by the specs 1 and 2 of HDBaseT. So that means 4K 30 444 at 8 bits per color, or 4K 60 420. Those formats are supported today uncompressed. When HDMI came along, the data rate, the character rates increased to 600 mega character symbols, and that equates to 18 gigabit data rate. Now, in terms of resolution, that meant that now I can support 4K at 60 hertz refresh rate, 444, and even 4K 60 at several, HDR content, which is 10 and 12 bits. That's what really HDMI 2 introduced. And it's a big escalation from, the early days of having SD-TV, and when HDMI was introduced, you had full HD. With HDMI 1.3, which is, there was an upgrade to 10.2 gigabit, and that's when 4K 30 really come into play. And this is what HDBaseT has been able to support uncompressed for many, many years. And again, when HDMI 2 came along, it supported much higher resolutions and refresh rates, but the data rate increased all the way to 18 gig, which cannot be sent uncompressed over an HDBaseT2 link. So what was the solution from HDBaseT as an alliance? They looked at many technologies, and they came to the conclusion that the best was to use a mezzanine type of compression, such as DSC. And the reason that they chose DSC is because this is an open compression standard defined by the Visa organization, and it's low latency, extremely low latency, and it is basically what's really considered visually lossless. So the idea here is that you would have, as a manufacturer, let's say if you're designing a product with DSC, you would have HDMI 2 coming in from, let's say, a Blu-ray player, and this would have 18 gig. The DSC compression will bring it down to 9 gig with no latency. Again, it's less than a line latency, so microseconds. HDBaseT would then send it over a standard HDBaseT2 link, and on the receiver side, you would receive that link and then decompress it and send it like for like to a TV. So from a video point of view, this is by far, the best solution using the existing technology, and it's the only solution that was verified and ratified and approved by HDBaseT's alliance to work with their technology. Again, a little bit more information on DSC if you don't know, but it stands for display stream compression. It was developed by Visa, who is a well-recognized standard by loads of different manufacturers, but they basically developed this standard, and it was adopted by major, all the big display interfaces such as DisplayPort, HDMI 2.1 supports DSC, the MIPI. If you don't know what MIPI is, it's the standard for connecting cameras inside of your phone and so on. Mobile HD Link also uses DSC, so it's a well-known, a verified standard for compression, and it's not a proprietary one like many manufacturers are doing today. This is vigorously tested and recognized as a visually lossless technology with no latency whatsoever, or less than a line. What does this mean for you? So this table is important. You can take this table, make a print copy if you want, and when watching this video. But let's say for 4K 30 Hertz, it means that every resolution that went above HDMI 1.4, i.e. anything above 10 gig, was not previously supported. With DSC, you're now able to support a lot, if not most, of all those standards. So anything that is 10 bits or 12 bits should be supported with DSC, as long as it's not got any active dynamic HDR content such as Dolby Vision and HDR10+. However, it does support HDR10 and HLG, which are the most popular HDR formats worldwide today. For formats for 4K at 60 Hertz refresh rates, again, it supports exactly the same now. So anything with the 10 or 12 bits are supported, as long as it's not obviously HDR10 plus or Dolby Vision, because those have dynamic packets that cannot be compressed. So just to explain a little bit why that is because Dolby Vision, for example, uses metadata which is inserted into the video itself, into the video packets going over the HDMI, and when you compress the video, you obviously affect that metadata, and because of that, that's not supported over DSC. However, it does support all of the HDR10 and HLG formats, which are not supported, if I'm honest, by manufacturers that are using color space conversion as the method for compressing 4K 60 HDR formats. I have a separate training on this. If you want to find out more, please go to the installer's hdbasett.org website. You will see a bunch of webinars there. Please go to one of the Pulsate trainings that I gave. You will see in there, and I'll explain a little bit more why you should go with DSC rather than other proprietary technologies when choosing to support 4K 60 over HDBaseT2 and 1. Okay, so that's a very quick highly technical, I'm afraid, but hopefully you followed overview of HDBaseT1 and 2 and what is supported up till today. Now let's move to HDBaseT3. What is new? So looking at it from the technology point of view, the big change is that now there's a big increase in the bandwidth for the main link and also on the return link. This is completely different between the version 1 and 2. There wasn't really an update on the bandwidth available over the main link. With HDBaseT3, there is. It's doubled. So instead of 500 mega symbols, it's now increased to 1,000 mega symbols. So that means that it's doubling the bandwidth over that link. So if previously we said it had an 8 gig bandwidth, now it has a 16 gigabit per second main link from source to sink. And again, it's increased the symbol rate over the return channel as well as the modulation. So instead of PAM8, it's now PAM16 for the return, and that allows you to have a return channel of 2 gigabits per second. And separately, it's improved the retransmissions and so on in order to counter any sort of external noise that might affect the packets going over the link. So it's a big change compared to HDBaseT2. And what does that mean in terms of video resolution? So we've talked to HDBaseT1 and 2 can send HDMI 1.4 uncompressed over that link, or it can send HDMI 2.0, but it would be compressed with DSC. With HDBaseT3, HDMI 2 can be sent fully uncompressed over that link. So that is the big change. Other changes as well is that you're now able to send multi-channel audio on either direction. The USB bandwidth increases, so it supports full USB. It has some other features such as HDCP 2.3 sort of integration into the chips itself, so the manufacturers will become much more cost effective of implementing the solution. A big change really for the Pro AV market is increased from 100 meg Ethernet to 1 gig Ethernet. And also you will start to see some products that can work. A single SKU can be a receiver or a transmitter. It's what we call port duality. So not all products will do that when they start, but there will be products in the market that can support port duality with HDBaseT3. So single SKU would be able to support that. From our point of view, we in this training, we're really looking at the video portion of HDBaseT3. And as I mentioned, because of the increase in bandwidth, it means that HDBaseT3 can now support the TMDS character rates of 600 mega characters per second, which is what HDMI 2 supports today. This translates to HDBaseT3 at 16 gig can support uncompressed HDMI 2. That means that an HDBaseT3 product can now send Dolby Vision and HDR10 over the link because it's not having to do any DSC compression, which obviously, as I explained earlier on, destroys the metadata. Whenever you do any compression on Dolby Vision, you actually destroy the signal and not getting the full HDR content on the other side. So this is a big improvement, and obviously uncompressed is always best. So to summarize a little bit between the first spec, the second, and now HDBaseT3, 3 sends all of the HDMI 2.0 formats, can send them uncompressed. Regardless of what you're sending, it is supported. And there's also a forward path to supporting HDMI 2.1, and obviously that will likely be using DSC, but that is future-proof rather than something that's available today. Other things to note is that you support different audio capabilities, so you can send obviously speed if you're always able to send an HDBaseT2, now with 3 as well. Stereo support is fine, but now you can send multi-channel audio on either direction, and that means that you can support eARC with HDBaseT3. And again, because you're sending the information uncompressed with HDMI 2 over HDBaseT3 link, you can support every single HDR format regardless natively over the link themselves. So this is a big step and a big compared to other solutions out there in the market, both over HDBaseT2, but also over video over IP solutions available today. So coming back to the table before, let's start with the 4K at 60 Hertz. You will see that with HDBaseT3, there is nothing that's not being supported, regardless of whether you're sending Dolby Vision, the number of bits, you know, every single format is supported at 4K 30 Hertz. And for 4K 60, the same thing applies today, as long as you know the bandwidth is HDMI 2, i.e. below 18 gigabits. For formats where you might require 4K 60, 444, 10 or 12 bits, although those are not available today really in the residential, but let's say if you did want to, those are HDMI 2.1 formats, and therefore they will be future supported with DSC, but they're not supported today. But anything HDMI 2.0 supported over HDBaseT without compromise. And what does that mean in terms of cabling? So how does HDBaseT 1, 2, and 3, what are the cabling limitations? What should you be looking at? So let's start with defining the cabling and improvements that have happened over the years, first of all. So obviously the category cable is a twisted pair cable carrying different signals. You have 4 twisted pairs inside a single category cable, and those are used for Ethernet as well as HDBaseT. So let's start with Cat5e. Is the first cabling that really was designed to meet 350 megahertz bandwidth. Cat5 is 100 meg, but the improvement to 350 was really because enhanced Cat5, as it's called, is really improving the or tightening, shall I say, the specifications over the crosstalk between the different pairs, and that allowed a much faster bandwidth over the cables itself. When you move to Cat6, it actually improved further the performance. It was mainly better insulation between the pairs, it lowers the attenuation. So really, if I was to do an installation today, the very minimum that I would be recommending people is to use a Cat6, because you have a much better sort of crosstalk and noise control really between the pairs that you have over Cat5e. And finally, Cat6a, it really is an improvement in performance. This cable was designed to meet 500 megahertz bandwidth, which allows you to send on Ethernet a 10 gig, but a 10 gig signal Ethernet, but HDBaseT allow you to send basically HDBaseT3 signals without compromise. So if you look at the HDBaseT3 specification, it actually mandates that you must use a Cat6a cable shielded USDP as a minimum if you want to achieve the full 100 meter distances at the full bandwidth. And not going too much into cable construction here, but just to explain a little bit, obviously a Cat6, you will have some crosstalk between the different pairs because there's not much isolation, although they are tightly regulated in the twisting of the pairs itself, but there's no really anything stopping some crosstalk leaking between the different pairs. As you move to Cat6, that's not the case anymore. There's much better, you have you have better insulation between the pairs, and you also have some form of either a foil or a ground wire in order to improve the grounding of the cable, and obviously the return loops itself if they're forming inside of the cable. So Cat6a really is a big improvement on Cat6. And then Cat7 has even better insulation and immunity from external noise. These are the sort of cables, when looking at bundling lots of cables together, I do start to recommend, obviously, to use Cat6 and above, in particular Cat6a, because obviously you have better immunity from different cables that are nearby. on external noise. Now, going back to HDBT3, I mentioned that it's specified that you must use a Cat6 rated shielded cable, but that also applies to the connectors. There's no point in having a shielded Cat6 cable if you're not using shielded RJ45 connectors. Now, I understand that RJ45 connectors, the Cat6A, probably cost a couple of dollars each. So it's a big increase from a plastic connector, which might be a couple of pennies or tens of pennies. So you might think, oh, that's a big cost increase. But when you look at the entire cost of the installation, this is negligible. You should just do it, because if you're putting plastic connectors, what you're really doing is making sure that that shield, which was meant to be acting, as its name suggests, as a shield, now becomes an antenna. It picks up external noise, which is affecting the signal, and it also radiates noise to nearby signals. So the idea is that you should, for the shield to be effective, you need to ensure that it's a continuous grounded from source all the way to the sink if possible. And that includes not just the connector, but the patch panels, the cables. Everything should ensure that both the cable and the connectors are fully shielded. Okay. So as I mentioned, don't use plastic connectors. Make sure that all the patch panels are also shielded if you want to avoid having an antenna and causing yourself more problems. In terms of cabling recommendation, this is a slide I put together, but it's an important one. First of all, let's look at the different HDBT specifications and the type of cabling this supports. So for HDBT3, you obviously is recommended that you use a Cat6A or Cat7 cable. You can use lower grade cables, Cat6 or 5E, but your distance will drastically reduce, and it's not really recommended. We strongly recommend that you stick to Cat6A. If you're wanting to send 4K 60 420 at 12 bits or any HDR 10 bits, your data rate is going to be below 12 gigabits per second. In this data rate, you can support 100 meters without compromises, with two patch cables at either side, one on the sink and one on the source. However, as soon as you go up, let's say you want to support 4K 60 422 HDR or 4K 60 444, which uses the full 16 gigabit bandwidth. In that case, you have to be careful. If you do use patches at either end, notice that the distance drops to about 70 meters. But if you have a straight run, there's no problem. You can use the 100 meter that's claimed in the technology. The reason I mention here is I mentioned right at the start that when doing patches, it lowers your distance or it has an effect on the signal. On HDBT, it can be quite severe. So every time you have a patch on either side, your rule of thumb, it varies obviously, but the rule of thumb is that you're reducing the distance by about 15 meters. So if you've got two patches at either end, you can see that it's now 70 meters. So the best would be, when possible, use a straight run. You're much more stronger. You're not affected. The signal quality is not affected at that point. For HDBT2, there really is no compromise for the resolutions that it supports. It can support 90 meters or 100 meters, depending on the type of cable that you're supporting. So obviously you can support 100 meters of Cat6A and 90 meters, up to 90 meters of Cat6 or 5E at the forward bandwidth. This also includes with DSC. So let's say that you're sending 4K 60 444 with DSC over a Cat5E cable or Cat6, you can achieve 90 meters or 100 meters with Cat6A. With HDBT1, because it didn't have that immunity improvements, the distance is a lot lower. Oh, not a lot lower, slightly lower, I should say. It is 70 meters at 4K 30 Hertz, and it's 100 meters, still the standard at full HD 1080p. So this is important. It's a nice table, and I think it highlights really the maximum resolutions versus the cable and the technology. So it gives you a good range of what you're able to achieve. From our point of view, from Pulse 8, we are now recommending our customers that if you want to achieve 4K 60 444, we recommend that people start moving to uncompressed where possible. And that means that for new installs, you use a Cat6a, Cat7 cable. This is by far the best cable and best solution, and you're able to support HDR10 and Dolby Vision at 4K 60, or uncompressed, no compromise. However, we understand that in some cases you want to do a retrofit. So if you don't have Cat6a cable and that particular installation is limited to Cat5e or Cat6, then you still can achieve 4K 60 444, but you will need to use HDBT 2.0 with DSC. And this is by far the best solution for, over an existing cable installation, i.e. the retrofit. So that's a quick, fast overview of HDBT1, 2, and now the big improvement on HDBT3 and why it's so important to send HDBT3, is able to achieve uncompressed and therefore support Dolby Vision and HDR10 Plus over a 100-meter category cable. Now, the next question that I normally get asked very often is, what about video over IP? Why should I stick with HDBT instead of video over IP? And I tend to tell customers that, well, you shouldn't. You need to understand what are your requirements and pick the best solution for your specification. So a few of the things that you will require in a residential installation. I know it changes for commercial and professional AV, but for a residential installation, you will start to look, first of all, video quality. Am I having to handle 4K HDR resolutions? Is it at 60 Hertz or 30 Hertz? Do I need Dolby Vision at 60 Hertz? All of these things you need to ask and really try to understand from the end user if it's a must. The second is latency. You want to really, in a residential, want to prevent lag as much as possible. You want to allow a clean switch in between sources so the panel doesn't go blank. But second, also, if you're moving in through a menu, that there's no lag when pressing the remote, and then obviously that video reaching the display. And there's other reasons why latency is important in residential. Cost. Very important. So what is the total cost per zone when you take all of the equipment put together and then you divide it by the number of zones? Is it really more cost effective to use HDBT or video over IP? And that's important. And it changes depending on the size of the installation and the features that you want to support. Control. Is the equipment that you're deciding to use user-friendly? Do you require support for different third-party control systems? If you don't have the budget for a third-party control system, does the equipment that you're using allow for, their own control system? So for us at Pulse 8, we have our web UI mechanism, which allows any end user to control the matrix without having a third-party control system, although we work alongside them. These sort of things are important when making your decision. Distance. Is 50 meters enough? Is 100 meters what you require? Depending on your installation, you have different options, both available. So for short distances, there might much more cost-effective options than if you need 100-meter distances, for example. And how complex is that installation? Do you need to, the easiest is obviously plug and play. You come in, you plug them all in and it works. You're in the site very little. And obviously, the less equipment that you're using, the less points of failure, you're reducing the number of points of failure in your installation. So ideally, you want to plug and play. If not, you want a minimal setup and the least amount of equipment in that installation whenever possible. Flexibility. You know, do you require that flexibility? Is that property large enough that it's likely that you're going to need more screens than what is currently specified? For example, video over IP offers much more flexibility than HDBaseT, which have usually fixed matrices, and therefore if you're jumping from an 8x8 to 8x20, it's much harder to do than with a video over IP. So that also comes into play. You need to understand what is going to be required in the future. And low maintenance, and this depends again. You want to prevent picture loss. So one of the things that we talked about is uncompress. If new formats come in, new HDR standards come in, whenever you use compression, it might not support it. When you use uncompressed, what comes in comes out of the other side. So, you know, you're less likely to encounter interoperability issues or future interoperability issues. Second, does the equipment that you want to use have some remote monitoring capabilities? For example, those things need to be considered when making the installation itself. And video over IP does offer some improvements for larger installations, I would say in particular, but it does have some challenges in the residential market. First of all is that in residential, you need 4K 60 Hertz HDR distribution today. And it has to be cost effective, and it has to be, you know, has to remain flexible, but you need to maintain the video quality and latency. And depending on the standards, you might affect the video quality and your features might not be supported. And in some cases, latency is too high because compression that you require in order to send it over a lower bandwidth infrastructure means that it takes longer to decompress on the other side, and also you're adding more artifacts to the picture. So it's always a compromise on what you need. There is a small but rapidly growing, I would say, number of IP support solutions supporting 4K 60 444. I would say that there is a trend, and particularly on the residential, I'm not talking commercial, by the way, but in the residential, there's a trend towards going to a 1 gig and 2.5 solutions because they tend to be more cost effective and better for retrofits. There are 10 gig video over IP 10 gig solutions like SDVoE, and these are actually suitable and very good for new installs, but they are also have some cost prohibited in some aspects as well. So they might not be practical for many of that installations, in particular medium-sized installations. It tends to be better on the larger ones with a big budget. A lot of people use broadcasting codecs. So codecs are obviously compression, decompression on either side. So the broadcasting ones like H.265, for example, are perfectly adequate for streaming, but they might not be suitable for time critical applications, which residential really is one of them, because as soon as you start adding latency, you start to have a bad experience from the end user. So those really are not generally recommended for a residential installation. But the final thing is that most video over IP products today do not offer a practical way or a native way of sending Dolby Vision or HDR10 Plus at 4K 60 over their link. They're having to compress the video, and therefore that's affecting the Dolby Vision HDR10 Plus metadata when doing so. HDBaseT by far, unfortunately, still remains the most cost-effective solution for small and medium-sized residential installations. So anything where you require less than 10 displays tends to be best for using HDBaseT. Anything above 16 displays, so large installations, then I would say video over IP is probably offers higher flexibility and scalability in doing so. In between, and I don't know the number, but anything between 10 and 16 zones, there is a compromise, and you have to decide whether to use HDBT or video over IP. And that depends on features, on scalability that you might have in the future, and so on. So really, it's a compromise on what you need for that particular install. The good thing about video over IP, and again, it's not all bad news, is that there are some technological advances happening. So Semtech have released obviously an ASIC solution a couple of years ago. Previously, what that means is they've released a chip that does SDVoE internally, and that's the AVX family. Previously, SDVoE was being done in an FPGA, and by bringing it into an ASIC means that the total endpoint solution really drops in price. And that's helped to make SDVoE a little bit more price competitive. Although when you look at the overall solution, it still remains relatively high compared to the cost of the HDBT. There are also some advances in the different codecs for 1 gig and 2.5 gig that are allowing what is classified as visually lossless, although that's obviously depending on what side you side, but they're very good basically codecs. They're offering low latency, and people like, so the technologies like Colibri or JPEG XS is now being implemented in different solutions, and they offer really an improvement on the performance, even if they do have reasonably high compression, but they're also cost optimized. So, you know, they're making improvements themselves. And then from the transport layer point of view, the broadcasts have really fully adopted SMPTE 2110. And there are many reasons for that. It allows real-time uncompressed video to be sent over as long as the network allows it to. So if you have a 10 gig and you want to send, 4K 30 uncompressed, it allows for sending that active video over the link without having to do any codec compression. It also allows for audio distribution, which has become very popular with the AES 67, and obviously Dante sort of utilizes part of that as well. You have a common reference clock, which allows frame-to-frame sort of switching. So if you switch in between sources, you can do that without a blank picture, and dynamic rate control. So that means that you can utilize your video over the same network as your Ethernet network, and you can utilize it all in one rather than having separate sort of networks, one for video and one for the Ethernet for the network itself. So your IP network, should I say, IT network. So dynamic rate allows you to, first of all, allocate bandwidth to the video, but also do higher or less compression according to the bandwidth available and so on. So there's some good things happening on the video IP, and I think the next few years are quite exciting, but in some cases we're not there yet. So I put this slide to try and put a comparison chart of many different factors when you're doing a 4K 6444 large installation. So we discussed previously that obviously for smaller installations, HDBT is probably the most cost-effective and best video quality solution. But what happens as the installation gets larger, as it gets to 16 by 16 or even above, you want to add more zones into installation, what happens? So I tried to look at the different technologies themselves and make a comparison, obviously, between the different ones and what are the compromises that you need to make. Again, a lot of this comparison not just depends on the size, but on many other factors themselves. For example, whether you want to send different signals, what type of equipment you're using. But anyway, it's a good comparison table for you to use when making those choices. So if we look at it, we start with, let's say 16 by 16. This is what I'm taking into account. And we want to basically just use HDMI inputs and outputs. Now, obviously, the cost of such equipment, there aren't that many in the market, so it's reasonably high, which means that although you wouldn't necessarily have, let's say if it's a short distance away, obviously you wouldn't have an extension solution. So the total cost per zone is medium or even low because you don't have any other equipment. But the main factor is that installation flexibility is poor. So as soon as you have that equipment 16 by 16 and you want to go by a 16 times 17, because you now got 17 zones, you can't easily expand that without throwing away the switch completely. However, in terms of video quality, is obviously the best you can get because it's uncompressed and the latency is next to nothing because obviously there's no extension solution there. And the same thing really happens with HDBT. Now, you would have a switch that does 16 by 16, but there aren't many available, and the cost of them is quite high. Now, that means you also need the receiver, and the total cost per zone is reasonably high as well. The biggest problem, the biggest challenge is that your flexibility is also poor. And that's because, again, if you want to go by 16 times 17 or 18 zones, you now can't do that. You have to throw away your HDBT switch and try and buy a much larger one that might actually not even be available. However, as we discussed during the presentation, the video quality is the best that you can get. It's fully uncompressed and you can send it with no issue. And again, in terms of latency, there's no compression, there's no decompression on the other side, and we're talking a couple of microseconds delay, and that is it. So this is where technologies like SDVoE, for example, come in. Now, they're able to offer, first of all, flexibility. As soon as you go into IP, the main benefit is that I can now put an Ethernet switch. And if I want to go through a 16 times 18, I can now add a second switch and make it part of the network without having to throw away my previous switch and the other. So I can put another 16 by 16 switch and keep on adding. So now you have a 32 by 32, for example, and obviously you would connect them through the backbone, each one. However, the cost of a switch at 10 gig is still relatively high, although prices are going down. The problem is that if as soon as you connect more than one, you need a large backbone bandwidth, so much more than 10 gig at that point on the backbone, not on the main ports. And the total cost per zone is quite high because by the time you add the cost of the switch along with every single endpoint available, the cost of an SDVoE endpoint is quite high still, although again, it's coming down in price, but it offers you a good flexibility. You can increase, and that's the main thing. And the second good thing about this is that the video quality, because you've got a large pipe, it means that in most cases you don't need to compress, so you have very good. But as you go at 4K 60 444, you do have to do obviously a very slight compression. So the video quality is very, very good. In terms of latency, we're talking way below subframe. So, you know, this is a good alternative, although obviously you still need a reasonably high budget in order to support it. When it comes to JPEG XS, another of the new sort of low latency technologies, but much higher codecs. So these are able to be flexible, support 1 gig, 2.5, and even 10 gig networks. But let's say that you want to do the highest encoding possible at 1 gig. So the cost of the switch is reasonably low today for a 1 gig switch and even 2.5. However, the total cost per zone might be, you know, reasonably high, medium to high, I would say, because the endpoints today are still quite costly. The reason for that is because JPEG XS, as an example, you still need to use an FPGA. However, in terms of installation flexibility, it's very good. You just have to add another 1 gig you know, switch if you want to go above, the existing infrastructure. And then in terms of video quality, we talked a little bit about it. It's very good. I would say it's obviously not as good as SDVoE in terms of because it has a much bigger pipeline, but still the encoding itself and decoding is very good today, and it offers a very good alternative if you want to reach 1 gig sort of networks, and obviously install it in a, let's say, a retrofit where you have a Cat5e cabling, then this is not a bad alternative to use. And then the latency again is subframe for this particular codec. So it's what's called a mezzanine type of compression, still at this high level of encoding. And then you have other technologies, the JPEG 2000, where in fact there's several chipsets available, but most people in our industry are using the A-speed chip. The good thing about this is, again, you're using a low-cost switch. The total cost per zone is medium, because first, the switch cost is reasonably low, but also the endpoints are not too expensive either, because they're using ASICs. Installation flexibility, as I mentioned before, is very good. You have a very inexpensive switch, and you can just add more switches as you go along. The video quality is very good to good, depending on the amount of compression that the chipset is making, but generally is very, very good for JPEG 2000. However, the latency is much higher. You're now having to go above a frame of video, and obviously you'll start to see that effect as you get longer latency. And finally, if we're talking about a broadcast type of technology, normally they have very, very high compression. So you can actually send it obviously through 1 gig, but you can actually send it through 100 meg if required as well. So that would have bigger compression and decompression. So the cost is low. Total cost per zone is very low because the endpoints are low cost as well as the switch. Installation flexibility is very good at this point, because now you can use, your backbone only needs to be 1 gig in order to send several video streams. So that offers a lot more flexibility, but the video quality is reasonably poor, but in particular the latency. The more that you're encoding and having to decode at the other side, the more latency that you're adding in on, and obviously the decoder has to work harder. So there is some compromises that you need to make, and I would say that really HEVC or H.265, sorry, is not really a good solution for a residential install usually. So I would be looking anything between JPEG 2000 or SDVoE if you're looking at JPEG XS. So any of these three tend to be the most common practices in our industry for AV distribution in the residential. Now, however, when you do reach this size of equipment, as you can see, you're having to make compromises between, video quality, cost, latency, all of these things, flexibility. And the one thing to note is that it becomes much harder to support HDR10+ and Dolby Vision natively over the link, because now you're having to do some compression. And as soon as you do compression, you're probably breaking the HDR content that's being sent with that metadata, sorry, shall I say, that's being sent with the video itself. So you have to be very careful whether the end user wants to support these standards of 4K 60, these HDR standards, and if so, maybe none of the IP solutions are able to help here. However, these are some of the compromises and some of the things that you need to make a decision in when deciding whether to use HDBT on or whether you want to move up to obviously video over IP and the scale of the installation itself. So in summary, HDBT was really revolutionary when it first came into the market. It became the de facto standard, and it remains the de facto standard with HDBT3. The reason is it is simple to install. It's plug and play. It has no compression, it doesn't affect the signal, and it remains the lowest cost per zone for small to medium installations by far. So if you've got the best quality and it's the cheapest solution, and again, there's more products available in the market from different competitors, it means that obviously the price is dictated by market conditions as well. So this would be still, and we continue to see with HDBT3, with the ability of sending uncompressed HDMI 2.0 over a 100-meter cat cable, it will continue to remain the most cost-effective for small to medium-sized installations, and that means anything up to 10 zones or outputs. With video over IP, however, it does offer more flexibility, as I mentioned, and reduces the total cost, ownership, or per zone really, in the larger installs. So if you're going above, and you know you're going to need to go above 10 outputs, you might want to start considering video over IP. But there are a range of solutions available, and you need to know the pros and cons of each, and basically make a decision according to what you need or the end user's requirements. Finally, something I haven't mentioned in this presentation, but obviously it's the elephant in the room, it is audio. So that will also dictate what video technology you want to use and what product you want to use. Obviously, if you need to extract the audio from the inputs in order to feed it to an amplifier, or maybe you want to feed it before that to an audio matrix switch, you need a matrix, the video matrix that can do audio extraction. If you want to support audio return channel, maybe enhance audio return channel as well. All of those things need to be taken into consideration when choosing your video solution and the end product switch or endpoint. Well, that is the end of the presentation. Hopefully that was interesting. If you have time and you're attending ISE Barcelona next week, please stop by at the Pulsate booth. We will be launching a new range of HDBT3 products. More information to come, obviously. If you are at ISE, we're right next to the south entrance. So that is the main entrance. As you come in, you walk into Hall 2. You will see us on the left-hand side. Just wave at us and come and have a coffee. Learn a little bit more about HDBT3. In the meantime, if you do have any questions, please do not hesitate to contact your Pulsate representative. And wishing you a good rest of the day, and thank you very much for listening. Goodbye.